Hi everybody, we are going to work on some similarity theorems. This is Mrs. Osier.
And Miss Perrier.
And let's get started. So the first of the two theorems that are for this learning target is the side splitter theorem. So basically you have a triangle and a parallel line is drawn to one of the sides. So that's what you're looking at here. When that happens, you want to remember the following. Parallel lines create proportional parts. Here is what that looks like. So I have triangle QPN as the large triangle in this picture, but I have a parallel line at RS. First thing I want to do is locate X, what it is that I'm looking for. And from there, I'm going to set up a proportion. Part to part equals part to part. That's what I always like to say with this. Anytime you have, again, this parallel line, oops, that did not just draw when I tried to. This parallel line, there it is. This part is corresponding to this part over here, and this piece corresponds to this piece over there. And then as always, you can draw your proportion in multiple different ways. When you cross multiply and solve, you get x equals 14. Showing it another way, if I do for solving for x for Jn, I have 16 over x. I can go left to right, and then I would go 20 over 38. Again, I went left to right. Remember, there are always 4 correct ways to draw any proportion, and you just need to make sure that you are consistent with it.
So this one, the opposite is also true. So here we go again. We got our side splitter theorem with our line parallel to our other line. So we got to show that they are parallel. And that is basically with our proportion right there. You got to do part over part equals part over part. And right here we didn't have an x. We have all the numbers here. But as you can see that they're parallel because they equal the same exact thing. So they will be proportional and parallel if they equal the same exact thing.
So just make sure you write that sentence after that work, and that's really all that you need. Now, something different that will look like the side splitter theorem. In this case, and I say be careful of the bottom, what I mean by that is the bottom side of the triangle. In this case, it's not the side splitter theorem, because when this occurs, we're not dealing with this side and this side. That's not what's happening. We're dealing with the small triangle and the big triangle. The reason that is so important is because 6 and x correspond, but here's the part that people usually get thrown off with. It is not 3 and 2. It would be 3 and 5 because it's the entire side of the triangle. It is not the side splitter theorem when you're dealing with those bottom parts. It's overlapping triangles, so I would encourage you to maybe draw them separately, because when you do that, you should realize that you have 6 and x on the bottom, 3 is the left side of the small triangle, and hopefully you realize if you try to write 2 right here, that 2 is actually just that part. This entire piece is 5. So that is why you have to be really careful of the bottom. It will look like the side splitter theorem, but it is not the side splitter theorem.
So again, we got another example, and that's just another example that we just saw. So everything is being labeled here, but we are getting the inside piece is what x is. So again, remember that you have to find the whole entire thing, which is 9, and that corresponds with 15. And then the 3 corresponds with the x. So again, there's 4 different ways to write a proportion, but here's the one that we did. 3 over x was 9 over 15, which x will equal 5 here.
All right, the next theorem is the triangle angle bisector theorem. This one, honestly, is the one that feels the least natural of the entire chapter. It's like, really, that's proportional? But anytime you have an angle that's being bisected, the rays of the original angle, so 40 and 24 in this case, are going to be proportional to the parts that are, I don't want to use the word bisected because it's not cut in half, the parts that are split on the opposite side, which are 15 and 9 in this case. So I'm going to highlight what that looks like. Here is that angle that's being bisected. So 8 and 12 correspond to one another. And then the parts opposite those congruent angles, the x and the x plus 2, are also corresponding. So our ratio is going to look like this. 8 is to 12, so side of the angle is to side of the angle, as x is to x plus 2. Side opposite the congruent angle is to side opposite the congruent angle. Cross multiply and solve.
The same exact thing for number 7 is what you got to do here.
Oh, sorry. I didn't finish clicking. Sorry. They asked for EF and FG, so after I found X, I had to substitute back in to get those. Sorry.
So again, we have to find RV and TV, and you set up your proportion here, and you cross multiply, and you find what RV, you find the Y, which is 15, and then you just plug that back in, and you get your two answers here. How you can tell that it's being bisected, the two tick marks indicate that as such. That means that they are the same. Just a little refresher there.
All right, a couple more examples here. So x minus 1 and x plus 3, and then 4 and 5 are the parts we should be looking at when you have the angle bisector in your proportion, and then you have to set your proportion up accordingly. Make sure you are consistent, cross multiply and solve, substitute back in because it's not asking for x, it is asking for the segments NP and LP.
And the last one for 9, it's the same exact thing. Make sure that you have your proportional parts. There's our angle bisector. So 4 and y plus 1 will be proportional, and 21 and 2y minus 4 will be proportional. So you set that up, you cross multiply, you solve for that y, and then you plug it back in. And then those are your two answers.
That's it. Those are the two theorems you need to know. You definitely want to have these notes out while you're working through, and we will see you in class. Have a great day.